Hey everybody, my name is Rusty Morgan. I'm with Propspeed, and yes, as Michael mentioned, we're a New Zealand-based company, but I'm based here in Washington State right now. But I look after the entire West Coast of the United States, so I'm really excited to talk to you guys today. And first of all, thanks Regina for that update from the Coast Guard. I think that every company here has a really unique contribution into getting some of the toxins and biocides out of the anti-foul systems, and I think that's the way the world is going. So it's really exciting to be here together with you guys, and I think this is going to be a good thing for the world going forward. So without further ado, I'll just get right into it. Our company has we've been around for 21 years, and we were founded in New Zealand, we were founded essentially as a way to combat the zebra mussel problem. We had these huge problems with zebra mussels down there that you'd put your boat in the water and it would be almost inoperable in about 6 weeks because there was so much growth on them. So we started by creating a foul release coating that was initially designed for propellers, but since then we've kind of split into a few other areas. We have a product called Foul Free that's a transducer coating that we use for all sorts of various things, and also Lightspeed, which is a clear foul release coating for underwater lights. As if you're involved in recreational boating at all, you know how popular underwater lights are becoming, and there's also some components of aquaculture and research vessels that are using underwater lights now for various reasons. So we're pretty excited to be able to have a product that we can offer to help those particular pieces of equipment. So Propspeed is our core product, and it's a silicone-based foul release product that essentially functions by creating a really slippery surface. We apply this to propellers and shafts, primarily, but we also do rudders, keel coolers, struts, through-hull fittings, swim step platform assemblies. We can do, we do IPS drives and DP systems on commercial vessels. So it's really, it's got a wide variety of uses. Some of the key points of it are that it's easy maintenance. There's literally nothing that you have to do with it. It self-cleans, so any fouling is just going to slough off of your running gear or metal components. It's got excellent corrosion protection from electrical related corrosion or galvanic corrosion. It's non-biocidal and it's multi-season use, so it doesn't matter whether it's in the water, out of the water, and we typically get between 2 and 4 years on this product, depending on the conditions of the water. So as I said, it's a silicone-based coating, and kind of the secret sauce here is being able to get the silicone to stick to a metal, and which has always been a challenge. I mean, the unique part about silicone is that it's so slippery, nothing really wants to stick to it. But the challenge there is that it doesn't really want to stick to anything else. So we've got a primer system and an application method that works really well. We've gotten the adhesion to be excellent. The process is not terribly complicated. Just about anybody can do it with a bit of training. When you put this coating on, you're going to get improved fuel efficiency because of the fact that you're reducing fouling on the surface of the propellers, and decreased maintenance. And one of the interesting things is we've found that there is an improved acoustic signature. Is in the propellers are effectively quieter than a dirty propeller. I threw this in just kind of for fun. Most of the people in this audience are probably going to be pretty familiar with how the silicone foul release coating works, but effectively you've got a hydrophobic surface, so you've got a very large contact angle. For Propspeed, it's about 105 degrees. And when you think about water beating up on a really high quality raincoat or a lotus leaf or some kale maybe, that is the same functionality that Propspeed provides. So effectively you can't, barnacles and underwater growth, that sort of thing, they can't form on the surface of something that's coated with Propspeed. Or sorry, they can form on the surface, but they can't attach. So the other product, and this is something that we're really proud of, we developed in conjunction with a company called Airmar, a coating for transducers. If you look at these pictures here, these are both standard ship's transducers, and they're covered in growth. And what we've seen is that there's this huge kind of boom in technology in terms of what we can see underwater with these transducers and these sensors. In addition to these huge leaps that we've found in the screens and the processors that are running them. So what that means is that mariners, whether you're recreational or commercial, have this incredibly detailed picture of the subsea surface. Well, if your transducers look like that, you've got this age-old problem that's really kind of causing issues for modern technology. So we are coating now these transducers with the foul-free coating, and we're keeping them clean, and we're keeping people able to keep that sharp image that they're seeing of the subsea surface. So we're pretty excited about that. Here's an example of a screenshot from a chart plotter, and if you see on the right-hand side, that was the side that was coated. The left-hand side was the side that was uncoated. So you've got a whole bunch of growth over here, and we found you lose about 50% of the resolution on these chart plotters when you have fouling. Another example is over here, and this is a company called RBR out of Canada that makes instruments for ocean research. These ones in particular, I believe, are oxygen saturation sensors. And we coated these, and this is a stationary sensor. And this was after a 6-month deployment. As you can see, there's almost no growth that's settled on these sensors. So just as a point of reference, these sensors used to have to be pulled out every 3 weeks to be cleaned manually. So we're saving these guys a lot on maintenance, but more importantly, the data that's coming through is very clean. Lightspeed is our other product. As I mentioned, if you're familiar with recreational boating, underwater lights are pretty common, but the problem is that they're warm. You get a lot of growth forming on the surface of them. Our coating is clear, so we can maintain the luminosity that you would have in your underwater lights. You know, it's just kind of a fun product, but it works really well. This is our point of sale display. You know, it's pretty recreationally focused, but it's a really unique product. And we found that there are some people who are using it in aquaculture to coat the lenses of cameras for counting fish. And there's all sorts of really kind of unique applications for products like these. And I think they're going to become more common in the market coming up here in the next 5 to 10 years. So yeah, we're really excited. So where is Propspeed going from here? We're a 21-year-old company. What's going to happen over the next 21 years? And I believe that we're at an inflection point where the marine industry as a whole is getting away from biocides. So with that, Propspeed is really searching for opportunities to test and evaluate the efficacy of this product in shipping, ferries, fishing, and defense in terms of longevity, efficiency, and corrosion control. So if you know, please feel free to reach out if there are any opportunities for us to test these products in maybe a situation that you have where you have excessive growth going on, or you have regulations that are preventing in-water propeller cleaning or that sort of thing. You know, we would be happy to work with you to find ways to see if we can mitigate that. We have a very active in-field team, and we work directly with partners to apply, evaluate, and test these products. I mean, right now I'm sitting in Port Angeles, Washington, working on a couple of projects out here. And we're really active. We get out there, we work with people. We, you know, I'm going to put on a paint suit in about an hour, and it's really fun to be able to be involved in the whole process, from the sales side of it to helping individual customers and helping to find solutions. So it's something we're really proud of, and it's great to be a part of this. So thank you again, Michael, for inviting us. And if there's any questions, please save them for the Q&A section. So without further ado, I will figure out how to stop screen sharing here.
Rusty, thanks. That is really terrific. It's interesting when I reach out to people and tell them about anti-biofouling. I've had a number of people say that they have used Propspeed on their props, and so you guys are doing a great job of making yourself known. We've got 2 other great companies that are going to be speaking. The next one furthest away would be from Nova Scotia, Canada, and I believe we're going to start with a short video, and then Marciel will be speaking. Is that correct, Mo?
Correct. I'll be the one who's sharing the video.
All right, here you go. I'm starting you guys.
Just let me know when you see it.
Not yet.
How about now?
Yes, we do.
And let me know if you can't hear it.
There's no sound there, Mo, if you want to try again.
I'll try again. Just 1 second. We tried this earlier and it worked, so there's the trick. Boom.
There you go.
Paint, I always thought was just paint, you know. But what we're starting to understand is how the paint works makes a big difference. So firstly, you know, the historical way that a lot of marine coatings were very harmful to the environment. Graphene, because of its hardness, because of its properties, is not harmful to the environment, and that's huge.
It doesn't contain copper. So as a biofouling, it's not poisonous to the environment. It's just a surface that's very difficult for life to attach to. The coating itself is very, very smooth. It's graphene based. It's an extremely glass-like surface.
We did the calculations on the potential for greenhouse gas emission reduction, and as well getting quite excited about the beneficial impacts around biodiversity because of improvements this coating can make around friction between the vessel and the water. These small incremental changes to fuel efficiency that you can get by getting a harder, smoother paint on your vessel saves money, and it helps us meet our greenhouse gas emissions and environmental objectives. The benefits of 1 or 2% reduction in fuel makes commercial sense. We're talking about hundreds of thousands of dollars and what appears to be a reasonable payback period.
You need a lot of baseline data to certify that, yes, this product works. And that's really where we've been working with GIT, is proving that the product does what it says it does. This product is going to revolutionize the industry in a series of ways. It's durable, it's going to give improved performance, less noise, and also better fuel consumption.
So the partnerships is really beneficial for Horizon. We're coming up with good ideas that are going to improve our environment. It's definitely going to make us more globally competitive in the maritime industry. It's a really good win-win-win for everybody.
Thanks very much, everyone. Marciel, please take the stage.
Marcel, you have a little over 6 minutes now.
Okay, perfect. Just share my screen over here. Everyone can see my screen?
Yes.
Perfect. Thank you very much, Michael and Mo, for the video. So my name is Marciel Gaier. I'm the CTO and co-founder of Graphite Innovation and Technologies. So at Graphite Innovation Technologies, we reduce fuel consumption, cut emissions, and recapture revenue for the shipping industries. So we are found by leading and experts in material science and chemists, and mostly working with graphene technologies and graphene as a nanomaterial, and use its strength for underwater marine coatings. So what we can do with this nanomaterial that is graphene, we can decrease the friction or the drag of the hull. We can also reduce the corrosion, reduce or eliminate the use of biocides and toxic elements into the ocean, improve the hull longevity, reduce biofouling, and lower the overall maintenance costs. So a little bit more about the customers here that are currently on the works, you can see some examples of the Horizon Maritime fleet vessels that are currently using and will be also using our product. So this is what we call the Xjt product line, starting with Xjt Fuel, which is an environmental friendly hard fall release system. It's biocide free, and because it has a super low friction and low roughness, it decreases fuel consumption for the marine industry and shipping industry. And that's all based really on the properties of the graphene. And this product is also certified by Lloyd's. It has the type approval of Lloyd's register. So a little bit more on the product line, Xjt product line. We also have Xjt Shield, which is an anti-corrosive product. Xjt Prop, which is focused in protects your propeller against cavitation and biofouling and wear. And Xjt Stealth, which is a coating that aims to solve the new issues of the shipping industry, which we're going to talk a little bit more in the next slides. So how do we reduce underwater radiated noise, and how do we reduce fuel consumption for the shipping industry? That's pretty much comes out that when we talk about biofouling. Biofouling accumulates, slow down your vessel, and makes it less efficient. So we want to keep your surface roughness of your propeller very smooth. As well, you want to keep your hull surface very smooth. And you do that using a hard fall release system that you can clean it and you can scrub it in the water. So it's very important to do a biofouling control analysis and optimize your ship speed to really reduce those emissions. So a little bit more about underwater radiating noise impacts on marine life. So we know that primarily shipping noise that really affects our whales, our fish, seal, lions, dolphins, is the 10 hertz to 1 kilohertz range. So that's the focus of the underwater radiation noise paint, is to reduce the impacts of that. The core of our company really is to be environmental friendly company. That's why we funded this. So we are concerned about the climate action, life below water, innovation infrastructure, and decent work and economic growth. So we are indeed very concerned about the environment. A little bit about partners of the company. So we work very extensively with the government of Canada, so Transport Canada, Lloyd's Register, which we actually have Jim here, I think, from Lloyd's Register. He's watching this presentation as well, and Horizon Maritime Shipping Company. A little bit about the projects we're working on it. So 2 projects on 2021, about $7 million that was captured in the Q1 of 2021. And what we're looking for today is channels, distribution partners, investments to advance our underwater noise technology. And something as well to remember that if you make your ship quieter, you also have advance in defense and military applications. So we mentioned here defense agencies and military applications, technologies partners, and customers and companies for collaborations. A point there that our company is built on collaborations. I also want to mention that I see in the chat list there, Mario from San Diego that has significantly helped the company, and as well Captain Elias now in San Diego. So I have my contact information here. Happy to talk, happy to answer any questions. Thank you very much.
Thank you, Mo and Marcel. That was really good and great work. 2, really interesting companies, and congratulations on the funding that you have received as well. So our third company is represented by John Bowlin, the president of SeaCoat. And John, hopefully we will give you the floor and the access to the screen. You are on mute, John. John, you're on mute. There should be in the upper right-hand corner a little microphone, if you can push that. Tamara, can you help him?
I think the other option is to hit the Command, Shift, and M, John, on your Apple. Nope, no good. John, in the same place that you share your screen, it should give you the option to unmute. I can only mute you, I can't unmute you.
You may have to go out and come back in, John. John, you may have to go out of the program and come back in. The only thing I can think of. And for the rest of the people in the audience, we're hearing quite a bit of background noise from someone. This is why we do a trial run 2 days before, so sorry for that, but this may be a problem in Texas for all we know, since John is down near the Houston area.
Okay.
John, you're back. Okay, good.
Okay, great.
Can we hear you?
Great.
I'm also experiencing a few delays on things here, John, so
Okay.
I understand. Just glad to have power, remember.
Exactly. Well, good morning, everybody, and thank you very much, Michael and Tamara, and the TMA organization for the opportunity. My predecessors, both Rusty and Marciel, did a fantastic job of laying down a little bit of groundwork here, so everybody's got the lay of the land as far as what we're all dealing with. So let me just see if I can get this thing started up here, which let's see. I need to be set up as a presenter, I guess, because it's not allowing me to share.
Hopefully Marcel released the screen from the last time.
Stand by.
Yes, I did. I canceled my screen share.
Thanks, Marcel.
Okay. Let's see.
The funniest part is, John, I don't even see you on the participant list right now, so I can't change your setting.
Oh goodness. Well, I'm in. I guess. Let's see here.
Go ahead and try again.
Okay, something's happening. Here we go.
Looking good.
Okay, can everybody see this?
Yes.
All right, perfect. Well, we'll start it off. So again, my name is John Bowlin. I'm the founder of SeaCoat. Started this thing back in 2001, and I'm the chief cook and bottle washer, as they say, off the cuff. So SeaCoat and SeaSpeed are my brainchild, and we started this back years and years ago to try to come up with a solution for biofouling, to try to reduce the fouling on ships, as well as make some incremental benefits for the ocean, and try to keep it clean. And of course, having had a few boats in my day, try to alleviate the issue of scrubbing, which is not fun if anybody's ever done it. So we'll proceed. if I can get this to move forward here. All right. Anyways, I won't belabor the point too much, but basically these are the key issues that I think the industry is dealing with, not only in the commercial but military as well as the pleasure craft industry. So we won't spend much time going through that. Essentially, what we've done is come up with a game-changing technology that's taken years and years to to hone down, and we've gone through a number of versions, about 6 different versions of the material. And what SeaSpeed is a 2-part material. It is based on silanes and siloxanes, which are again derivatives of silicone. We have some proprietary IP in terms of trade secrets with regards to the molecules that this material has been developed from, and the process by which to make it hard. And as you can see on this photo, we've got a standard bottom coating on the left-hand side, and on the right-hand side is the surface finish for the SeaSpeed V10X Ultra, as we call it. This material is ultra smooth, so basically it can generate savings in terms of fuel upwards of 12%. And we've done this for many years, gradually increasing the the effectivity of the coating because of the smoothness factor as well as hydrophobicity. So we can do it. We've been around, like I said, 19 years. We've proven this over the years numerous times and with increasing efficacy. So we've been able to get our coating down to a surface roughness of only 5 microns, which is quite smooth. Most of the coatings that we compete against, and I think this goes for all of the 3 companies here, most of these depletive type coatings, the toxic type materials, are typically in the 125 to 150 micron range, which is something that is quite different in terms of fuel efficiency. Basically, you got about, for every 10 microns difference in surface roughness, it's about 0.5% in fuel. Again, we have a proprietary technology that we've maintained as a trade secret. Extremely hard, abrasion impact resistant type material, and also hydrophobic. And it does inherently similar to the Propspeed, since we both come from the same genre of technology, if you will. It has a non-stick surface, except in this case it's a very hard surface. Some of the accomplishments of SeaCoat over the years, again, we've gone in and done a fair number of large ships. Actually, we're about 49 large ships right now, because we have one in progress, which is essentially complete. We've done quite a bit of work with the Navy over the years, actually starting in 2001, and we had for 13 years, we've had a sole source contract, which we've furnished coatings for over 400 vessels. We do, our system is a 10-year coating. We have put it in extremely harsh environments and operating conditions, such as this high-speed ferry you see on the top right there. And it has logged some significant miles and at very high speed, which we'll get into a little more. And again, just to summarize, we've got proven fuel savings, emissions reductions, and higher top speeds. As we can see through this chart, this is basically going back our history with the larger ships, which these are 700-foot or larger vessels. We have done 49 of them, as I said. And as you can see here, what I've pointed out is the different versions based on the chronology in the years. And then also here you can see the difference in the surface roughness or average coating roughness of each evolution of product, if you will. And over here, you can see the change in terms of the fuel efficiency that's been the yield that these various products have garnered over the years. A little bit of a business case here, or case study, if you will. Again, this is a very high-speed ferry that's operating in South America. Coated it in 2010 with a previous version of the SeaSpeed, the V5. As of 2020, that vessel has logged over 1 million nautical miles at 50 knots. She also sits 67% of the time, which is quite significant. So it does have the opportunity to foul. After 10 years, we measured the film wear, and we're less than 1/10 of 1%. That gives you a good indication of the durability. This is a slide kind of detailing some tests on our new V10X Ultra, which we've done in various places around the world. We test our material everywhere in the world that you can think of that has any fouling to speak of. On the right, you can see panel that has been in Australia, basically the Coral Sea. That's been in there for a couple months on a static basis. And on the top panel on the right there, you can see that it's been cleaned with a wet paper towel. The other panel is off the coast of France last year. This is after 90 days static, and it's cleaned with a sponge. So it does have easy release capabilities. We have absolutely nothing in the material that will kill any kind of organisms. Basically, to summarize things, again, novel chemistry, highly proprietary, a proven track record of 10 to 12%, fuel savings. And if you cut the fuel usage, you naturally cut the carbon emissions. We can we warranty our material for 10 years. We've actually had some coatings on vessels for in excess of 14 years. But we right now at this point are putting a 10-year warranty on our material. Essentially, our goal is to lower the operating costs and the maintenance costs for ship owners, cutting the fuel consumption, extending the repaint cycles from 3 to 5 years to at least 10 years. It's a non-toxic material and non-depleting, as you can see from the performance. Essentially, what we've done is gotten this material down to a cost point, which is very, very similar to top-end anti-fouling paint that's going to last you 3 to 5 years. So the bottom line is we want to basically cut the overall cost or total cost of ownership for the ship owner, whether you're operating a fleet or whether you've got a yacht, or even down to the guy that's got the little 17, 20-foot boat. As far as the future for us, again, we've got a 19-year track record. We're dealing with a very, very large global market in the range of $4.25 billion a year. We have presence all over North America, Europe, Asia, Australia, but we're looking for additional distribution partners, customers, and potentially always looking for investors. And at the end of the day, we've got your bottom covered. End of story.
Thank you, John. We ran a little bit over because you had a little trouble going out and coming back in. So Regina, I'm going to turn it over to you at this point. 3 great presentations, 3 interesting companies, and you're involved with the IMO and you're involved from the Coast Guard, and be interested to get your reactions and questions that you have.
Well, my one comment to all 3 presenters is that the Coast Guard's primary reason for regulating biofouling is for biosecurity reasons, for invasive species. And I don't think any of you really focus on that biosecurity aspect as much as you possibly could. And the North American Emissions Control Area requires ships to burn ultra-low sulfur diesel, which costs considerably more than regular marine diesel. So I think the environmental benefits of reduced emissions in the emissions control area, particularly, and biosecurity, I think, are important factors. So, if you'd like, I'd like to take some of the questions. We got some questions in the chat. I encourage you to continue to have some questions in the chat. I'm gonna.
Hey, Regina, could I hop in here a little bit?
Yes, please.
I had a really interesting conversation with Mario Timbury, who you probably know. And he made a comment, and I didn't mention anything about invasive species, but one of the most interesting things that I heard Mario say was that they had worked a lot with ballast water, and ballast water is very expensive to deal with. But as soon as you can reduce, well, what he said was that about half of the invasive species arrive on attached to hulls and running gear. So if you can reduce that attachment, you give companies a financial incentive to use these types of coatings, because not only are they going to improve their speed and fuel, they're also going to reduce their aquatic invasive species loading. And I think that's a really important component. To get companies to adopt this sort of technology, you need a financial incentive for them. And I think that's a really important part of it.
Yeah, Rusty, I couldn't agree more. With ballast water, you have to spend a whole lot of money for something that gives you no direct operational benefit. For anti-fouling coatings, you can get a payback on those. So there is an economic incentive to be environmentally friendly, for sure. I have a general question about the silicone technology, and I'll address this to Rusty and John, or either one of you. Can you tell us a little bit about how this technology developed for the use on hulls and ships?
Right. Well, I guess back in the 60s, silicone technology was originally developed by GE, and they got involved to a certain degree, primarily with the Navy, the defense industries, and they found that it did work, but it was very, very expensive to apply, terribly touchy to apply, and most of the materials, let's say the soft silicones that are in the marketplace today, which are classified as duplex type silicones, they again are quite expensive, very labor and product intensive in terms of coats, and they have a lot of problems in terms of the let's say the environmentals during application, whether it be temperature, humidity, timing. Also, they found that many of these older duplex type materials essentially would leach silicone oil, and they still do. And that's how it developed, and they've gone through a number of different iterations. They're on the third generation of soft silicones these days, and these are primarily some of the larger companies out there. So that's how it started. Then they've proven that it does significantly improve the fuel consumption, and it does reduce the fouling, but for a limited initial time period, and that varies depending on who you talk to, between 2.5 and 3 years before incremental cleanings are required to maintain a clean hull. They seem, that duplex type technology seems to be, I guess, diminishing in market acceptance, for a number of different reasons.
Okay, thanks. Thanks for the history there. John, I have a follow-up question for you. Your coatings last 10 years, and I wonder how that syncs with the dry dock schedule that for most ships is 5 years and for some is 7.
Right.
Can you skip a dry dock with an underwater inspection?
Usually you can skip a dry dock without underwater inspection. The other thing is that you can, if you come up, you're gonna maybe have, propeller work. You're gonna have, any kind of shaft seals or anything like that may need repairing. But typically you take if you have a coating system that is fully intact after 5 years or even 10 years, basically you do a high pressure wash, some spot repairs here and there. do your other work, and put it back in the water, which will cut the dry dock time and expense by a huge factor.
Okay, thanks. Okay, this is a question for each of the technologies. What are, and this came up in the chat questions, what are the environmental impacts? I think these are non-ablative coatings, so what are the environmental impacts during installation or cleaning or maintenance? And I think that's of interest to quite a few people on the call.
Marcel, Rusty, you guys want to tackle this initially?
Let's pick
Yeah.
on Marcel because he hasn't said anything yet.
Perfect. Thanks, John. Thanks, Regina. Yes, I think that's a really good question, and I think it's really important. So, as we see, we start to do a full life cycle assessment of the ship, right? So we have the paint from when it's being manufactured. So you have to consider your sources, right? If you're using green sources versus petrochemicals. So as more of the bio-natural source that you can use, the better. And then you also have your VOC contents, which are super important. I think most of us agree that you want to be as high solids as possible. So pretty much all the paint that you spray in there is built up on your thickness of your film. It's not just evaporating. And that will also increase the protection of the ship that you have, which is really important to consider. And as well is a hazardous for the applicator, right? So you don't have the fire issue, you don't have the environmental, and you have a more green alternative during the application. And then we also have to consider the lifetime of the paint when it's in the ship in the water. And that will include the microplastics. Is it degrading in the ocean? Like John mentioned, coatings that were early on released, such as Intersleek 1100 SR, they say they don't release biocides, but they do release silicone oil. So does that have an impact in the ocean? Oh, I bet it does, right? But it's a new issue that is coming up. And then we have to consider the end of the ship, right? So you have to remove and blast the paint off once it's not working anymore and dispose that. So you have to do that in a recyclable manner when you can take that and maybe reuse in some of your process for the paint manufacturer again. So it really needs a full life cycle assessment of the paint, the use, and plus the whole environmental benefits of the fuel consumption, the ships, the emissions, and so on.
Right. Well, the other thing is especially the in-water cleaning, and primarily this is for the larger commercial vessels and military craft. That with these types of coatings that we're dealing with, they don't contain, at least ours doesn't contain any toxins whatsoever in there, and these don't slough off. Okay, in terms of actual usage running through the water. But even in cleaning and underwater hull cleaning, I believe, Marcel, your coating does not slough in any way, correct?
Yes, correct. And I think you are 100% right in that one. I mean, clean a biocide base close to shore is just, it's a horrible thing to do, because you're really releasing those huge amounts of biocide into that specifically spot where you're cleaning. So the coatings that are in the market that are biocide, the cleaning in water is really not an option.
No, and it's being banned more and more at different places, not only in North America, but all over the world. I mean, many countries and ports will ban hull cleaning in those ports.
Yeah, and then you have issues with traditional fall release coatings that are soft, such as the soft fall release systems that, again, if you clean them, you ended up a lot of the times damaging the coating and flaking off.
Right.
So I think that's some of the advantages of SeaCoat and our hard fall release system. And Propspeed as well, because they are all hard coatings that can be cleaned, so they biocide free and they have the environmental benefits. And that is where we see the shipping industry really moving to ongoing biofouling management systems, just including everything in all the analysis, right? You do have to be an active concern of keeping our hull clean.
Thanks, guys. I would like to put a question out to the audience, and you can just type your answers into the chat. If I'd thought about this ahead of time, maybe I'd have a little survey like some of the fancy people do. But if you could just let us know, what are your main concerns? What are your highest priorities about using AFS? Is it fuel savings? Is it emissions reductions? Is it green targets? Is it corporate green policy? What are your highest priorities? And if you could just feel free to type those into the chat box. I think it would help our presenters today, and it'll help us kind of focus more on questions to ask and things like that. I do have a question for Marciel. I looked in Wikipedia to see what graphene was, and it said it was a semi-metal that was similar to massless relativistic particles. I hope you could maybe provide something that would be a little simpler version of the massless relativistic particles for us.
Right. That's I guess a physics term, but in a general language, if you think pretty much that your pencil of your pen, that's a graphite, so that's a building, right? So if you take every single floor of that building and you shave it off and you make it very thin in a nano level, that's called graphene. And the advantage of that is that it's very strong. Yeah, it's the nanomaterial version of your pencil lead material, and it has these amazing properties because of its nanochemistry.
Well, that makes a little more sense. Thank you. I appreciate that. So I have a question that was asked of two of the presenters, and I think probably we could get an answer from all of you. What is the advantage of your product for electrolysis avoidance? Like for corrosion?
Yeah, I think that, well, I can speak for our product, but I'm making an assumption.
I might not have asked that question the right way, but I think you know what I mean.
Yeah, it's interesting. That's one of the kind of side benefits of most of these coatings. Like take a copper-based anti-foul, for example, right? You've got a binder of some kind of paint or whatever you're doing, and copper is your biocide. Well, you can get electrical transmission directly through that paint to a steel hull, to a bronze propeller, to any of this stuff. As soon as you're wrapping any of these components in, well, at least for us, for silicone, and probably for John, for you guys as well. I can't speak to graphene, but I know for silicone's an excellent insulator. So we, as I had typed in the comments, typically we see a anode load reduction of about 50%. And one of the kind of side things that we deal with is a lot of boats that have galvanic corrosion or electrolysis, we call it electrolysis, but electrical corrosion related issues. We find that applying silicone coatings can slow down or stop that. Now, you can't always completely stop it, but essentially you're insulating, instead of having a bare wire out there, you've got a wire wrapped in this insulation. So I think that it's not, it's a little bit of a difficult thing to quantify, but I do think it's a huge benefit of these products. And Marciel, can you talk a little bit about graphene? I mean, does graphene have any of those properties? I thought that it was a conductor.
Yes, that's a good question, Regina. So corrosion, really, there's several mechanisms where it can happen, right? So for example, when you have your bronze propeller spinning and then your steel hull, you obviously have two different metals and one of them is moving, so you're creating always that AC current, right? and that's why you use your active anodes for corrosion protection. And a lot of the ships, they apply anti-corrosive primer as the first layer to the metal, right? So the kind of graphene that is superconductor is the multi-layer graphene, and it's only if you use it by itself. We're not coating the whole ship with pure graphene. That would be completely insane. But we do use those particles in a certain way where they do have insulation properties. So if you look really into anti-corrosive properties of graphene, because these nanoparticles, they are huge in flake size, but they are nano into your thickness size. They do block the oxygen diffusion and the hydrolysis of the system. So you do have, in addition to the fall release performance, the anti-corrosive benefits. So that's why we call smart multifunctional marine coatings, because they have more than one function of not only having the fall release performance, but also the extra anti-corrosive and mechanical performance.
Right, Marcel is absolutely right. But the silicones are, they prevent the air, and they also are great as far as non-permeability to water or even gases for that matter. So you take those issues out of the equation, and you can diminish the electrolysis and or corrosion on a hull or even propellers significantly. And we've seen the same thing in terms of the load on the anodes, where you'll see anodes and zincs last 2 to 3 times as long with a silicone, type coating, because it is non-conductive.
I think it's important to mention that when you reduce that load on the anodes, you're reducing your aluminum or zinc that's entering the environment too, because I think it's something we can't really do anything about because we have to have those right now. We don't have another option. But as talking about environmentals and keeping everything out of the water, the more we can do with that, I think the better.
Totally agree. Thank you, guys. So one of the other emerging concerns is underwater noise. And I know Marcel mentioned that the graphene has some, I guess, dampening effect on noise. How does that work? And does silicone also provide that kind of dampening for underwater acoustics?
Right. So that's actually a good question. I think I have a picture here of what we envision. So you have your anti-corrosive primer as the first layer you apply to your metal. And then on top of that, you apply your noise reduction coating. So our noise reduction coating actually doesn't have graphene. It's just have these proprietary particles that scatter the sound inside the paint into that specific frequency range that the ships really emits the noise. Now, what's important to say is that that won't work for the propeller noise. You work for the engine and internal parts of the ship. For the propeller noise, you do need a propeller coating to increase your cavitation inception speed and so on. So that will be a different mechanism, but it is a combined effect of isolating your inside noise, so the vibrations from your engine propulsion systems, and as well making your propeller very smooth and keeping as much as possible the original shape, so your tips and your blades don't cause cavitation, which will cause the underwater noise.
All right. Well, the other thing too is that in some systems, for instance, with ours, because it's a hard system as well, but ours is a silane siloxane material. We do put a nano material in the coating as well, and this acts as a sound barrier, if you will, in order to stop the sound waves or interrupt the sound waves, if you will. But the other key thing with regards to silicones and in terms of noise, and predominantly with propellers, is you change the actual laminar flow of the water, okay, going across the surface. which essentially reduces the point of cavitation. And the cavitation is basically bubbles, which is quite noisy. So once you can improve that laminar flow, reduce the generation of bubbles, you inherently make it quieter.
Yeah, I would add in there, John, I think, you know, what we have found is that propeller roughness, right, increases over the lifespan of the propeller. So if you take a polished prop with no coating on it and you put it in the water and you use it, the cavitation is going to, because you have these bubbles, they're going to break down the metal at the surface of the propeller. You're going to create a more rough surface, and as soon as the surface is rougher, it's noisier. And
right.
And it's pretty hard to quantify, but it's definitely noticeable. And I think with the silicone coatings, absolutely, you reduce that, you cut that cavitation down a lot. And you maintain that surface roughness profile for longer than you would if you had just a bare metal on a propeller.
Absolutely.
Okay, I have one last question, and anybody can jump in on this one. And we've had a number of questions about whether these coatings can be applied to aluminum, steel, fiberglass. Now we have a question about wooden boats. Are these generally applicable to any surface? Are there exceptions or limitations?
Well, with SeaCoat, we can tell you we can go over virtually anything: aluminum, wood, fiberglass. Actually, the SeaCoat material is the new Ultra material was designed as a direct to gel coat type material, but it can go direct. We can put it over anti-corrosive primers and commercial applications. So all of the above for us.
Yeah, we primarily work with metals, just because the nature of that it's designed as a running gear coating. But we also coat composites like fiberglass, gel coats, polycarbonate, glass. We do some stuff with the high-end racing yachts with carbon, coating clear coat on top of carbon fiber and that sort of thing. And it all comes down to surface preparation and figuring out what works for the particular situation. Plastics are challenging. We found that there's plastics have really high surface energy, so they don't really like anything to stick to them. But we have found some methods of being able to get things to stick to plastics, and that would be primarily for research instruments like those RBR sensors that I showed you. They're made of ABS plastic, and if you want to paint ABS, good luck. But there are ways to do it, and but I would say plastic's not a very common material seen in marine applications.
Let's let Marcel answer, and then we're going to have to wrap up.
Yeah. Well, that's a good question. I mean, our paints and is the same as John and Rusty mentioned. Is all about surface preparation. So you do have to do the right surface preparation to guarantee the proper adhesion and to the substrate, whatever it is. It's all about surface prep.
I feel like we have an embarrassment of riches here. We have three leading innovative anti-biofouling companies that are going to help change the world. And, we're trying to figure out where they can be applied, which sounds like many places, most places. And now you get to the audience gets to decide which one's the best for them. Regina, just before you go, you also are the U.S. Coast Guard representative to the IMO. Can you just, are these the kind of technologies you want to bring back to the IMO so that they know these exist? You're on mute. There you go.
Yeah, I was thinking, I hadn't unmuted because I was thinking, we don't really bring technologies to the IMO. The IMO sets out to find global compromises, and they generally trail industry, and they generally often trail U.S. domestic regulations. So I track plastics, anti-fouling, biofouling, ballast water, sewage, gray water. I track a bunch of stuff at IMO, and I would not look to IMO to be the leader pushing new technologies. I think if you look at the industry standard that came out recently, that's the only standard we have right now for in-water cleaning and for biofouling management. And it probably exceeds what will come out in the revision of the IMO guidelines. So right now, I think that is probably your best bet about how things will be going. I think the innovations are welcome in the shipping industry, and I think it's only a matter of time before they take off.
Thank you.
I have a question, if you don't mind me asking. Just one more, Michael.
We are at the witching hour. We're at 9 o'clock. Marcel, is it something you can do separately?
Yes, for sure. No problem.
I think we ought to do that. We pride ourselves on trying to end right on time. Tamara, if you'll just bring up the last slide again. And I want to thank our speakers. You guys have been amazing. Very, very professorial as well in terms of some of the answers that you gave. Every one of our themes are a little different, but all of your presentations and the video will be available online probably as early as tomorrow. We work really hard to get them up. For all of our audience, I think it's really important that you help us get the word out, that there are incredible technologies around the world. Please send people to the TMA YouTube website where this will be posted. I think tomorrow we'll be sending a link to everybody that attended as well. Looking forward, we have events on water wastewater in March with NASA on the intersection of the BlueTech and space economy. And then in May, likely with the National Oceanography Center, the NOC, on ocean sensors, the circular economy. Thank you to our partners, the BlueTech Cluster Alliance, which is 10 leading clusters in 8 countries. And then the BRINC is a organization at University of San Diego involved in as an incubator accelerator that we work closely with. A special thanks to our cluster partners, the U.S. Coast Guard for, of course, moderating this event, and the 3 companies that spoke. And then finally to all of our attendees. Thank you for spending an hour plus of your time with us. We're thrilled to be bringing great technologies from around the world. And please help us in thanking the speakers and the moderator today. So thank you all very much. We look forward to seeing you all again soon.
Thank you very much.
All right. Thank you very much. Bye-bye.
Bye-bye.
Thank you, Michael. Bye.
Bye.